In this video I'm going to show you how you can come up with the equation for this sine curve. So this is your sine curve of period 7 and the amplitude is 3. It's been moved across by 2 and up by 7. So let's try and come up with the equation for this curve. So we know that normal sine of x, when this is 1, we know it has a period of 360. If you apply this transformation, it means you squash it by a factor of 2. So we have a period, it will have a period of 180. If you squash it by a factor of 4, it will have a period of 90. We've already done this, so I'm expecting you to know this. So what you've got here is when the coefficient is 1, you know you would have a period of 360. When the coefficient is 2, it will have a period of 180. So you know the relationship is that when you times this by 2, then you divide this by 2. You know if you times this by 3, then you divide this by 3. And when you times this by 4, then you divide this by 4. It has that kind of a relationship. And also if you apply this transformation, you would stretch it by a factor of 2. So it's going to get stretched out like this. So this will be 720. So you know that if the coefficient is a half, then this would be 720. So it means that if you divide this by 2, then you times this by 2. So we know the relationship is that if you times this by 2, you divide this by 2. If you divide this by 2, then you times this by 2, and so on. We know it has that kind of a relationship. So here the trick is we want a period of 7. So we've got to create a sine graph in such a way that it will have a period of 7. So what we do is we take it down to 1. So at the moment it's 90. So let's take it somehow. We're looking for a coefficient where it will have a period of 1. So we're looking for this mystery coefficient where it will have a period of 1. Well, if I divide this by 360, then I know I'm going to times this by 360. So if I have this 360, and then this will give me a period of 1. So what that means is if I have this 360, it will give me a sine graph where the period is 1. But now I want to times this by 7. If I times this by 7, if I times this by 7, so now I will have a period of 7. That means I divide this by 7. So what it means is 360, and then I divide by 7. So this is our coefficient here. If we stick this into here, into the coefficient here, then it will give me a period of 7. So what that means is to create a period of 7, we need to have this equation here, 360 over 7x. So let's test this out in Desmos. So jump to Desmos. Jump to Desmos. So these two points are here, 2, 7, 9, 7. We want to create our sine graph. So if we have, make sure you're in degrees. So go to this spanner. At the moment you're in radians. I will explain what radians mean in the future, but for the time being we're just going to use degrees. So change it to degrees, and then go back to here, punch in sine bracket 360 divided by 7x, close it off. So now you can see that it has a period of 7. See right there, one cycle is 7. So now we need to So now we need to change the amplitude. So we've created a period of 7. Now notice that the amplitude is 3. So at the moment we've created a sine graph where the period is 7. Where here the amplitude is 1. We need to change it so that it has an amplitude of 3. So to do that, to do that? Well, at the moment we've got this. At the moment we've got this. Hang on. At the moment it's what weather? Hang on. At the moment we've got this sine of x. This would give us a period of 360. We would then apply this transformation 360 over 7x. That would then give us sine 360 over 7x. That would then give us a period of 7. Now we need to change the amplitude. So let's apply this transformation. 360. Well, stick a 3 in front here. So that would be 3 sine 360 over 7x. So if we modify our equation in Desmos, it should change out the amplitude. So hang on, Desmos, stick a 7 in there. There, it will have a period of 7. So hang on, not 7, 3. We want an amplitude of 3. What did I say earlier? Hang on, 3. Yeah, we want the amplitude of 3. So now it has an amplitude of 3. 1, 2, 3. So now we need to move it across. So at the moment we've got this. At the moment we've got a sine graph looking like this, where it has an amplitude of 3. Hang on. Where we have an amplitude of 3. Now we need to move it across by 2. So hang on. So at the moment we've got this thing here, f 360 over 7x equals 3 sine. So this is a current equation. What was it? 360 over 7x. So let's call this whole. Let's just give this a new name. Let's just call the whole thing g of x. It's a new function. It's just a new name. So this is our new name here. This is just a name of this graph at the moment. We want to move it across by 2. So we need to make this transformation minus 2. This transformation will move everything across by 2 towards the right, in this direction towards the right. So now that would mean we would put this into here. So that would then give us this 3 sine 360 over 7, and then x minus 2 bracket. Let me tidy this up by multiplying this out. So that would then be 3 sine 360x over 7 minus this times 2. That would be 720 over 7. There. So we punch this into decimals, it should move it across by 2. So hang on. So that would be this minus what was it? 720 over what? Over 7 was it? Yeah. So we moved it across by 2. Look, 1, 2, and then this is at 9. So now we just need to move the graph up by 7. Hang on. So now we just need to move everything up. So currently we are here at the moment. Now we need to move everything up by 7. So now the final stage. The final stage is to move everything up by 7. Hang on. Move everything up by 7. Hang on. So now we're currently here. Now move everything up by 7. So we need to apply this transformation. Get the previous graph and then add 7. So that would mean the whole thing here and then add 7. So I'm going to write over here plus 7. So that would then give us the whole thing 3 sine bracket 360 x over 7 minus 720 over 7, and then everything add 7. So let me erase this. So now let's test it in Desmos. So back to this. Oops. Back to this, and then add 7. So add 7. So now you can see that our graph starts here. It will have a period of 7, amplitude of 3. It's been moved across by 2 and up by 7. So this is our final answer. Okay.